All right, CNT125, we're on our voice over IP module. We're continuing this section on our equipment, if you will. So the next thing we mention is soft phones. Soft phones are basically a software version of your IP phone that you could have installed on initially laptops, desktops, laptops, nowadays even on your cell phone. Or I should say, excuse me, even on your smartphone, even on your regular cell phone, if you will. So it's things like, if you're connecting with a Cisco call manager IPPBX, you'd be using Cisco Jabber. That would be their soft phone that you can connect in, desktop as well as soft phone type thing. Things like Zoom, even Zoom soft phone for connecting into your Zoom cloud service provider, and I can even download a third party. Bria X-Lite was a soft phone we used in our lab room for a while, connecting to our IPPBX that we had. All kinds of flexibility, all kinds of versatility, and capability, a little bit even more so than your desktop IP phone, what it's able to do. And it's really just another phone in your network, if you will. And it can be home office, can be on your cell phone, etc. To make all of this happen, we have some protocols that we're going to add to the mix. So instead of just IP, TCP, UDP kind of thing, we're going to add in some additional protocols. We need signaling protocols. These are the ones that are going to set up, manage, and close down the phone call, if you will. These initially were proprietary, but have kind of standardized, that there's a couple standardized protocols that get used. SIP and Skinny are common ones that you run into. Session Initiation Protocol or Skinny Client Control Protocol. We run into this when you're running your Cisco equipment like we have in our lab room. That'll be the one we're going to run into. SIP, this might be something you run into out in office places and so forth, where you're connecting to, if we have an asterisk phone server, you're going to be using SIP to connect out to it. This is modeled after HTTP, basically kind of like a, hey, I'd like to make a call. Okay, let's make a call kind of model. All these different pieces is part of it. Okay, again, familiarity, just familiarity here, where you actually have a number of interconnecting of like, hey, let's connect, let's so forth, and it ends up looking like so when I boil it down. Your phone call that wants to make a call, your phone that wants to make a call, actually signals your phone's server IPPBX and says, hey, I'd like to make a phone call to blah. It passes it on to that blah phone B in this case, says, hey, we'd like to make a phone call. It responds back saying, okay, sure, let's do this thing. So then it goes, all right, you guys now go ahead and start talking directly to each other, and then the other protocol kicks in to pass the packet, IP phone packet data back and forth. So the signaling is there to be like, hey, I want to make a phone call, ring, 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 are you there? Okay, yeah, I'm here. Okay, pass it off, and now we start communicating directly. So that is the setup protocol. SIP would be the signaling setup protocol. You're signaling your setup protocol, your SIP signaling setup protocol. Just trying to help you sort that one out, okay? And this again is the kind of like a graph of like, hey, I want to try, it's ringing, okay, let's do it. And now we send the data back and forth. And then when it's done, it's like, okay, bye, let's close out. So SIP is the one that's doing all this control of setting up, and then when we're done, closing down. Skinny works very much the same way. Skinny works very much the same way, Cisco proprietary. So as we use our Cisco IP phones in here, we will end up seeing Skinny as our setup protocol. Hey, I'd like to make a call. All right, let me ring them. You're picking up. Okay, great. They're there. Now you guys start communicating. So again, Skinny is the signaling protocol to set up. Hey, I'd like to make a call. Ring, ring, ring. I'm here. Okay, let's do it. Boom, send the data back and forth. So your signaling protocol, either SIP or Skinny, is setting up the call, and when it's all done, closing it out. Okay. The transport protocol is the one that's actually going to transport the voice data, the actual payload, the voice payload, if you will. We know TCP is connection-oriented. It's delivery guaranteed for like file transfers and so forth. But we need something that's quick for moving our phone data back and forth, our voice data back and forth. So it's going to be UDP at the transport layer. Okay, it's going to be UDP at the transport layer, but at our upper layer, we're going to be using RTP, real-time transfer protocol. This actually operates at your application layer. Whoa, get back there, Mr. Brown. That operates at the application layer and is going to rely on UDP at transport layer. This is the one that's going to handle the packetized data between the two phones. So again, Zipper Skinny is going to set it up. You know, I'd like to call, ring, ring, ring. I pick up. Okay, you guys are connected. Boom. Pass your data back and forth. RTP is now the one that's going to take my phone data, packetize it, and ship it over to the other phone and back and over and back and over and back. That is going to be the one that is actually carrying our payload data. Okay, right here. Once it's set up, RTP is the one that's actually going to be holding on to or passing the phone data back and forth. Again, relying on UDP at the transport layer, RTP is actually operating at the application layer. So as we do a Wireshark packet capture in our lab, we're going to see SCCP for setting up. Once the digits are dialed and the phone rings and the phone picks up, boom, you're going to see RTP kick in to carry the actual voice data. Hey, I'd like to order a pizza. Okay, that'll be $13.99. Okay, that is the actual payload data then, that voice conversation. We also want to mention there is a real-time transport control protocol. This is giving feedback for basically what is the quality. Is anything being lost, connection errors, etc. It's not mandatory, but a lot of times this gets run. So you might actually see some RTCP packets in there as well. And this is kind of like gathering data on and providing information on the call. Last but not least, we want to make sure we mention quality of service. In our data networks, our IT data networks, as we start moving voice and video around, additional config usually gets put on switches and routers and so forth to say, hey, if this is actually voice over IP traffic, this is going to get priority. We'll send a couple of these packets through before we send another one. We'll send a couple of these packets through before we send another one. So quality of service can happen, or it should happen as you're moving your voice data through your networks. And that should be the end of our voice over IP module.